Hello everyone. Through this video, we are going to discuss the questions of exercise 1.3. So here goes the first question. Prove that root 5 is irrational. So here in this case, to prove that root 5 is irrational, we are going to consider first that root 5 is a rational number, and later on, while for proceeding with the steps, we shall show that root 5 is rational number. This assumption will be wrong. For that, one more concept we need to know. Two numbers, say A and B, are said to be co-prime if they have no other common factor, other than 1. That means A and B both are having common factor as only 1 and nothing else. Now in this case, first of all, while making the first assumption, we need to write, let us assume, on the contrary, that is why it is written. Actually, whatever is given to be proven, the reverse part we are considering means the false statement means root 5 is rational. That's what is assumed at first, and later on, while proceeding with the steps, at last we shall prove that root 5 is not rational, means our assumption is wrong. So here I am writing, let us assume on the contrary that root 5 is a rational number. Then there exist integers A and B such that we can, by definition of rational numbers, we can write what? Root 5 is equal to A by B, comma, B not equal to 0, and A comma B are co-primes. That means they have only one common factor, that is 1, and no other factor they have as common factors. So after this, I shall square both the sides of this expression, and I shall be getting 5 is equal to A square by B square. Performing cross multiplication, I can write here A square is equal to 5B square. This means what? Actually, we can express A square as multiple of 5. Therefore, it is very clear that 5 divides A square. Let's mark this expression as expression 1, because it will be required later on. 5 divides A square here. Suppose, for example, if I write 625 is divisible by 5, say 5 into Q. Now in this case, we can write it as 25 square equals to 5 into Q. The whole thing is divisible by 5, yes or no? Similarly, this 25 is also divisible by 2. So it means what? If A divides A square, it is must that, if 5 divides A square, it is must that 5 divides A also. Therefore, let A is equal to 5 into C for some integer small c. Now in this case, why did I assume A is equal to 5c? Because A is divided by 5. So in this case, A can be expressed as multiple of 5. Multiple of 5 means 5 into something. That something we are taking as any integer c. So after this, I can put this result in Roman 1, I mean the first expression. Therefore, 1 implies What can we write here? What can we write here? In place of a, I'm going to put 5c whole square, that is equal to 5b square. This implies 25c square is equal to 5b square. So cancellation will be there on both the sides, of course. On cancellation, what result did I get? 5c square equals to b square. This means what? B square is expressible as 5c square. This further means what? B is expressed as multiple of 5. Therefore, 5 divides b square. This further implies 5 divide b. 5 divides b. So from these two expressions, actually whatever conclusions we have drawn in these two parts, one thing is very clear, that a is divisible by 5 and in this case b is also divisible by 5. So it means what? A and b both are having one more common factor, that is 5, which contradicts the assumption that a and b are co-prime. So here we shall write clearly A and B have one more common factor other than 1. Here one more thing I can put, one more common factor 5 other than 1. This contradicts our assumption that A and B are co-primes. Hence, root 5 cannot be a rational number. So the final line, the conclusion we can draw here is what? Hence, root 5 is an irrational number. So that is how we can prove here. Next, question number 2. So in question number 2, what is given? Here this is question number 2. Prove that 3 plus 2 root 5 is irrational. So in this part, again the similar assumption we have to make. Let us assume, on the contrary, that 3 plus 2 root 5 is a rational number. Yes or no? Like the previous one only, we are doing rational number. Then there exist integers A and B such that, how can we write it? By definition of rational numbers, we can write 3 plus 2 root 5 is equal to A by B, comma, B is not equal to 0. This is in accordance with definition of rational numbers, comma, A and B are co-primes. This is the first and foremost condition to be fulfilled. Now, we shall try to keep the rational number, root 5, the term containing root sign alone in one side, on the left hand side. So first of all, I shall shift this 3 to the opposite side, A by B minus 3. Then after, I get here root 5 is equal to half of the later part we can take LCM here, it will be b, and in the numerator part it will be a minus 3b. So ultimately root 5 is expressible as a minus 3b by 2b. Now if we notice in the step, it is very clear that on the left hand side we are getting an irrational number, because the square root of any prime number is always an irrational number. This part is irrational. And if we notice this one, a is an integer, minus 3 is an integer, b is also an integer, and in the denominator part 2b, both are integers. So subtraction, addition and multiplication of integers can also be represented as integers. So numerator part divided by denominator part, in the numerator part also there is an integer, in the denominator part also there is an integer. So ultimately what conclusion can we draw for this right hand side? This is a rational number. Now, can an irrational part be equal to a rational part? No, this is impossible. Therefore, this is wrong. Means our assumption is also wrong. So we can write here, on the left hand side, root 5 is an irrational number, while on the right hand side, a, b, minus 3, 2 are all integers, and so a minus 3b by twice b is a rational number. Since irrational number is not equal to rational expression, hence our assumption is wrong. So ultimately what can we conclude? Hence the given expression means 3 plus 2 root 5. Therefore 3 plus 2 root 5 is an irrational number. So this is how we have to solve the second sum. Here goes question number 3. What is given here? Prove that the following are irrationals. Here goes the first question. 1 by root 2. Like the previous questions, here also the contrary part we have to assume. How we shall assume? In the solution we can write what? Let us assume on the contrary that 1 by root 2 is a rational number. Then there exist integers a and b, such that, now by definition of rational numbers, what can we put here? 1 by root 2 is equal to a by b, where b is not equal to 0. And what is the most important thing to be added here? A, b are co-primes. So after this, if we find reciprocals on both the sides, I shall be getting here root 2 is equal to b by a. Again, if we notice, it is very clear that on the left hand side, Root 2 is an irrational number because this is the square root of a prime number. Therefore, this part is irrational, while this part is rational. Why so? Because a and b both are integers. So, this part is rational. On the left hand side, root 2 is an irrational number. Yes or no? While on the right hand side we find what? On the right hand side we find that b by a is a rational number. Why so? Because a and b both are integers. Since irrational number, what can we write here? Irrational number is equal to rational number. It is never possible. Therefore, we must have to write here irrational number is not equal to rational expression. Therefore, our assumption will be wrong. Whatever assumption we made here, we have to consider that as wrong. So, how we shall write? Therefore, our assumption is wrong. Hence, 1 by root 2 is an irrational number. Similarly, coming to the next part, the next is Roman 2. Here the term given is 7 root 5. So here in this case, what do I have to write? In the same way we have to proceed. Let us assume on the contrary, the same way of writing, contrary that 7 root 5 is a rational number. Then there exist integers a and b such that by definition of rational numbers, what can we write? 7 root 5 is equal to a by b, comma, b not equal to 0, comma, a, b are co-primes. Means these two numbers are having common factor as only 1 and nothing else. So in this case, I shall try to keep this root sign alone in one part, alone on LHS. So it will be root 5 is equal to a by 7b. 7 will be coming to this side. So it is very clear that on the left hand side this part is irrational, and on the right hand side a, b, 7 are all integers. Therefore, this is rational. So irrational can never be equal to rational part. Hence, our assumption must be wrong. On LHS, root 5 is an irrational number, while on the right hand side as a, b, 7 are all integers, hence a by 7b is a rational number, of course. Yes or no? Is a rational number. Rational number. Since irrational number is not equal to rational expression. Therefore, our assumption is wrong. Our assumption is wrong. Therefore, what can we conclude? Hence, 7√5 is an irrational number. So that is how we can solve this question. And the last one we have here. This is the last question of this exercise. That is what? Roman 3 of question number 3. Here the number given is 6 plus √2. This question is something similar to question number 2 only. So coming to the solution part, same way of writing. Let us assume on the contrary that 6 plus √2 is a rational number. Then there exist integers. Of course, there will exist integers a and b, which we can use for writing a rational number here, where b is not equal to 0. Then there exist integers a and b such that what can we write here? 6 plus √2 is equal to a by b, comma b is not equal to 0, comma a, b are co-primes. So here what can we get? √2 is kept alone in one side, a by b minus 6 it is. 6 is shifted to the opposite side. Now here in this case, it is very clear that we can take LCM on the right hand side. What do I get here? B, then a minus 6b. I had to keep this root sign alone in one side. It means what? √2 is a irrational number. So why this is irrational? Because this is a square root of a prime number. On the other hand, on the right hand side, a minus 6b, these all are integers. So this entire expression is a rational expression. So what can we write? On LHS, √2 is an irrational number. While a minus 6b by b on RHS is rational, because a, then b, then minus 6 are all integers. So that's the way we have to write. But what conclusion can we draw here? Irrational number is not equal to rational expression. Therefore, the concluding line, of course our assumption will be wrong. Hence our assumption is wrong. Therefore, what can we write here? 6 plus √2 is an irrational number. Actually, initially we considered that 6 plus √2 is a rational number, but since irrational number cannot be equal to rational expression, as we got here, this expression shows that LHS is not equal to RHS. Therefore, 6 plus √2 cannot be a rational number, hence it is an irrational number. So this is the last question of this exercise, and with this exercise 1.3 gets over. Thank you.